Hello, Kim 121. This is Professor Ship, and I am here today to give you an updated video on chemical bonding. So, we've been going over chemical bonding for the past 2 weeks, and just in case some of you guys have questions, I am going to do some updated versions of the YouTube videos that you may have seen previously. So, I'm I'm going to provide you with some examples that you may be familiar with. So here's one that I'm going to start basic. Okay, so let's say that we have sodium chloride, and I told you to draw the structure. Well, the first thing you would need to do is find out how many valence electrons each atom is going to contribute. Now, I always like to show transitions whenever I'm using different elements and different bonds because I want you to see the transitions of new elements and new relationships. So I know that sodium has one valence electron because it is in group 1. I know that chlorine has 7 valence electrons because it is in group 17. So I'm going to add those numbers together and I get 8. Now, this is like what I call record keeping or bookkeeping, where you can write down each atom and its contribution in terms of valence electrons. And again, I'm going to show you a different version of chlorine, okay? And it's coming in with 7. And notice how I use 2 different colors. That's because I want to show you what happens when each element contributes to the process. Now, what you have learned previously is that chlorine is a part of those groups of elements that must have 8, okay? So if we talk about carbon plus all the elements in group 15, 16, and 17, they're trying to have 8 valence electrons, which completes what we call the octet rule, okay? And the octet rule simply says that in order to be complete, have a complete shell, you must have 8 surrounding its element. So I'm going to go back up here to chlorine, okay? Ooh, hold on. I'm going to go back up here to chlorine, and I'm going to draw the structure. So here's chlorine with 7. This is 1, 2, 3, 4, 5, 6, 7. So I've used chlorine, so I'm just going to slash that out the way, and then I'm going to go ahead and apply sodium. So sodium is going to go right here, and the one that it contributed, that little valence electron here, will go right there, okay? Now, chlorine actually has 8 around it, and so this completes the energy shell for chlorine. Now, the final pick should look like this, where you're going to draw a bond in between the sodium and chlorine atom, and you're going to replace those pairs of electrons with a dash. That is a single bond. But you must not forget to place those valence electrons around chlorine. So this is your complete picture for sodium chloride. Now, if I were to ask you, what are my non-bonding, how many non-bonding pairs of electrons I see, you would say, oh, that's simple. I'm going to go up here and I'm going to count. But let me go ahead and circle them for you so you'll know where they are. Okay? You would say that's 1, 2, and 3. So you have 3 non-bonding pairs of electrons, okay? It's that simple. Let's try another example. All right, let's look at another one where you have 3 atoms, H2, H2O. Okay, so you have hydrogen and you have oxygen. You've got to remember to separate each atom out, okay? You've got 2 hydrogens, that's where my 2 comes from. You have 1 oxygen, that's where my 1 comes from. Again, I'm going to show a transition of the new information. So I know that hydrogen, is in group 1. So that's where my 1 valence electron comes from. But because I have 2 of them, 2 times 1 gives me 2 valence electrons. Now I've got oxygen. Oxygen is in group 16, but it has 6 valence electrons. Remember, we dropped this 1 off from the 16 to get the 6. 1 times 2 gives us 6, of course, and we know we're going to add those together, and we end up with 8 valence electrons. Now, I'm going to come over here, and I'm going to draw out my 2 hydrogens, again, as part of my bookkeeping, and I'm going to add my oxygens. That's 2, 4, and 6. Now, again, once I've used those atoms, I'm going to mark them off so that way I don't have to worry about them anymore, okay? So here comes oxygen first. We're going to go ahead and put oxygen right there in the middle because it is the most electronegative element. So this is 2, 4, and 6. And if you remember, oxygen is a part of those elements, those group of elements that require 8 total valence electrons around it. So I'm going to go back and I'm going to add my hydrogens to each side of my oxygens. Now remember, because oxygen has 6 currently, but it needs 8, okay? It currently has 6, but it needs 8. It needs 2 more. We're going to pick them up from each of those hydrogens there. So here we go. I'm going to add hydrogen here plus 1 valence electron. The other hydrogen on this side plus its valence electron. And if you look at the middle element, there are 2, 4, 6, 8 total valence electrons. And guess what? That total number that you see in terms of pairs of electrons should also equal to this number right here that you've calculated. Okay? Now, of course, we're going to have to redraw this picture, and your picture will look simply like this. All you would do is just redraw those bonds in the middle and replace them with a dash. And don't forget your non-bonding pairs of electrons. They are important. And there you have it. This is your final structure. In the next video that I show you, we're going to show how you will do double bonds and triple bonds. So stay tuned for that. Now, as we talk about those double and triple bonds in the next video, I also want you to consider every time you have an element, okay? Every time you have an element, you have to remember how many valence electrons each of them will have. That is the main component to doing these types of bonds. Okay, you have to consider how many elements you're working with and what's going to go in the middle and how many are going to be contributed to each of them. Okay, so here's the joke that I gave to my students in my class a couple of days ago. I mentioned that it's like a cookout. You know, whenever you have people coming over to a cookout, barbecue, or gathering, you want to know how many people are going to contribute to this process or to the food, okay? So let's just say that carbon comes on and says, well, you know, it's just 1 carbon, okay? But there are 4 hydrogens coming along. Well, carbon says, well, you know what? I'm going to contribute to this cookout 4 valence electrons, okay? 4 valence electrons. And then each of the hydrogens says, well, I'm only going to contribute 1. Now, once you look at everything, you have a total of 8 valence electrons in terms of what's contributing to this particular cookout or gathering. Now, in order to determine what's going to happen to this whole process, you're going to put the element that you have just one of right there in the middle. So carbon says, well, I have 4 things I'm going to contribute. But y'all know I need 8, right? So carbon's like, I got my 4, but I'm still not happy because I need 4 additional valence electrons to complete my energy level to give me my satisfaction of being whole. So hydrogen says, all right, I'll go ahead and contribute 1 of me. Okay, so here we go. Here's hydrogen coming in. Uh-oh. Sorry, guys, let me erase this. There we go. So here comes hydrogen plus the one it's going to contribute. Here comes the second hydrogen plus the other one is going to contribute, the third hydrogen and the last hydrogen. So now carbon says, yay, I have 8 total valence electrons. That's what I needed in order to complete my energy level. So what we're going to do now is redraw this structure, and where there's a pair of electrons that are bonded to carbon, you're going to replace it with a dash. And this is your structure for carbon tetrahydride or methane gas. Okay? All right.